Welcome participants of this year's last webinar of CAN automation with the topic CANopen FD status and future. Few words about myself. I'm working for CAN automation for already a decade and a smidge. I'm supervising working groups in there, various working groups, CAN Excel based, higher layer CAN protocols, and so on. Besides that, I'm also doing testing of CANopen FD devices, CAN automation, and I'm also working as expert at one or two standardization committees from ISO, IEC. So CAN automation was founded with a purpose to assist users in developing devices, learning about CAN-based protocols. So we provide product marketing and technical overview over CAN-based technologies. That was our goal, and it continues to be even in these times. We built up a whole social network of many companies, many people who know about us. And one of them, and maybe another one, or the other ones, know a thing or two about CAN. And if you have any questions about CAN that you couldn't answer yourself, couldn't find in the books, then it would be a good step to contact us. We always find an answers to the CAN-based technologies and to your questions regarding this. CAN automation is located in Nuremberg. We have the only office in there. And the testing laboratory for CANopen FD devices is also located in this place. CAN automation is an organization which counts now about 775 members. The number varies over the years, but over the years we saw that interest in CAN is remaining, if not constant, then if not growing, then at least remain constant over almost 30 years in there. So, and that is, we are proud to announce that 30 years of existing of CAN automation. So, about what we offer as services, a couple more slides, about what are different topics we are offering as services in-house. In general, we are writing specification and we support users from various fields of application, either developers of device or integrators of the CAN-based networks. So get support technical information, how the things are done, how specification is to interpret, how do you find the devices if you're a system designer, where do you find devices? All this information you will find around our services in there. We have two arms of the CAN automation. From one side, we have to collect and put the direction of the money flow into certain projects of our members, which they ask us. For that reason, we have CiA marketing groups. They are doing all the stuff around finding new markets for CAN automation, for CAN-based technologies upon the request of our members. We are attending conferences. We're organizing CAN conference by ourselves to present the newest technology, newest developments in CAN. Also designing brochures where we describe what is new, what are the markets for CAN-based technologies, and so on. On the other hand, we, as I've already taught, write specifications, and offer some consulting services and testing services. That for writing specification is responsible another arm of CANopen called technical groups. It is organized hierarchically. There is an overseer committee that decides the total direction where we go with various topics, with various technical parts of development of CAN-based technologies. As you see from one side, there are so many fields that are grown in the last time, so we have to split them in different parts, such as for CAN protocol and physical layer, we have to design the whole subgroup, which includes many of those. It's called lower layers. It covers most of the protocol and physical layer specification and working groups working on the topics. One of the quite interesting this is work about CAN Excel. We currently having already standardized this new technology, CAN technology in ISO standard. And there is also a topic of how to evaluate what you see on your oscilloscopes and so on. We have some kind of meetings now within the task force physical layer, it is called, where we design how the scope manufacturers and transceiver manufacturers, CAN transceiver manufacturers, should interpret the so-called eye diagram, which folds in all the signals over the CAN message and folds all the parts of rising and falling edges, representing some distinguishing between the each bit of in a frame which you could see in a scope. So for that, we will have a big meeting. It's one of the interesting topic just on a as a corner case of what we have done. Beside that, we have also CANopen CC, and today's topic is CANopen FD. This is a whole different protocol, and for that, this is also too big to handle this within one small group. We have many subgroups in there, so it grows. Beside that, there are some border functionalities such as creating device from the scratch and handling the redundant networks. For that reason, we have organized the high availability group, which works on this topic as well. And there are special topics for task force to the bootloader and so on. Modeling is about actually representing abstractly the ISO-OC model. For various reasons we have to harmonize it with all additional functionality we offer now also, or will offer in lower layer protocols, such as CAN-based protocols. So a part of this security and safety, functional safety and cybersecurity is a big topic. So we have organized a group. Within that, we do have also some going on, working on progress. So CAN Automation has members. You may become member, have additional advantages, of course, plentiful. Of those, they are listed basically a few of them. You can get also some further information on our website. Member have some financial advantages and also especially has an opportunity to bring his technical requirements into a working group. This is the biggest advantage of the being a member. Of course, you may also design your devices or networks without being member. For that, you just may require to contact us. There are some optional and free available information for that reason, even free available specification. And you have to wage what you would do or what you would prefer and what your company would require in a previous stage. So thus we close with this the smaller block regarding introduction. And then we go into CANopen FD is in itself. So CANopen FD was developed, development, let's say, of CANopen FD was triggered by introduction of second generation of CAN-based CAN controller, CAN FD. CAN FD means, for those who don't know yet about this, CAN with flexible data rate. The key advantages, key properties, let's say, of this is a much higher payload, 64 bytes, in order to the classic CAN of 8-byte only, and possibility to use bitrate switching to go faster than it is possible with a classic CAN. For the moment, 2 megabits and possibly, not possibly, this is working also with 4 megabits, but with some application, it will be taken care of this whole stuff. Since it will be a most prominent market for CAN FD controllers, and it is already used and in plenty of cars at the moment, and slowly and surely industrial application get interested in using CAN FD controller. So for that reason, we've updated our CANopen protocol, CANopen application layer to the usage of higher payload and some other key advantages. So here we have listed basic protocols, which you may have remember or know from the classic CANopen, and there is also a list of bytes, a number of bytes indicating how big is an advantage in there. There are two protocols replaced in there, or say one protocol is replaced. Some other protocols, such as emergency and process data object protocol, is furtherly increased in size, changed at least emergency. It is not longer compatible, but it includes, for compatibility reason, the whole emergency message of classic CANopen. So we've introduced new protocol USDO. It allows some other interesting features. Beside that, we go into there. Check this out, how the PDOs will handle this case. So with the PDO, we have a structure, we have communication mapping parameter. So far, they are unchanged. There is not that much thing to change, to do in protocol stack. And the only thing we have switched, now this not maximum size of the PDO message is not 64 bits, but 64 bytes. So due to the number, there is no need to change anything in a protocol stack. The only thing is that bitwise mapping, as in classic CANopen, is no longer available with using only bytewise mapping. So then you can map all your bits into a single byte at least, to which was always also available in classic CANopen PDO communication. But the key advantage is that PDO is now can be up to 64 bytes long. An example of where it could be used is, for example, multi-access control. Then in one message, I can control up to 3 access of the drive of the whole system of tool. Additionally, it could be used also in medical application if you have to drive some injector and so with medical fluid injection for MRT or computer tomography and so on. That is the practical application. So why USDO was introduced as a new? Because classical CANopen SDO had some limitations. You needed to design additional channel to establish communication from device to another device or from the manager device of the network into certain devices where it is not about configuration or monitoring the current state of the network. So was required to design this. Now it is not necessary. It is not longer available. All the configuration is done in the data frame itself. There are key features of what USDO allows. Sorry, in general, there is now, beside the size of 64 bytes for the longer data content, especially for download and upload of firmware, for example, or longer data that you can do. There is single access for multiple indexes, which will be yet introduced. You can access also logical networks within, but there is specific information in there. We've got now, beside the node ID, there is also network ID, so we could design a network within a network. Logical network can address all devices with their network ID as well. But this information you will find also in specification 1301. So client server is not replaced, but was a classic STO, was a key to use to establish a channel to submit data. So you need a pair in both directions to get the message, since STO required confirmed data exchange. So a confirmation message had to be sent as well. Now in CANFD is no longer available because, as I said, all the configuration is done in a frame itself. So this configuration doesn't require, and I can access every device with just setting up destination node and network ID. So I know where my data goes or where do I have to get my data as well. So basically, as you know from classic STO, you have access of the smaller size objects that you have some 32-bit process value, whatever it might be. You can access this in one STO access called expedited access. For larger information exchange, for example, firmware update, or download of some data onto the device, segmented and block transfer was used. Segmented allowed it up to 127 segments to put in there. With introduction of USDO, this one is increased. It's not only faster transfer, but there are additional key features. Helping me out, helping the user out to know what exactly the segment is coming from. This means that the devices can trigger communication simultaneously, but despite the case, the message goes one by one over the bus, and I get response to the messages, you always know from whom you receive which segment. It was not previously possible. Now it is available. Also, the message is counted, so you know when it is stops in general. And of course, having much larger application in a very short time is, of course, of advantage in this case. For those who need some kind of much faster and larger download, there is also a pendant to block transfer called bulk transfer, has some additional features as well to indicate transport capabilities of the devices and the timing that is needed to reach this topic. This is all already included. For logical networking within the physical network, this is long distance USTO protocol is used. Now using network ID, you also can split physical network into several logical networks, and you can address all the devices by their specific network ID, which allows you better partitioning of your network within CANopen FD networks whatsoever. So USTO has some additional key features in contrast to STO, classic STO of CANopen. That is described where do you have this. If you need to go to details, check out our specifications well. And here is a small example for existing application for light electrical vehicles, how the network look like, and how USTO using its dynamic network accessing and this network partitioning can post the data around the whole system and goes across several segments of the network, even in hierarchical networking set in soever. So I wouldn't go into details in there. For light electrical vehicles, we have the specification, and for the more questions, you would kindly ask to write us an email to that. There are a few other key things I would address here that you might also be interested in monitoring of errors or storing some error information. Now it is available additional to this in kind of domain. So you could put not only as it's available in a classic one, just emergency code and couple more bytes of information, but it could be a large string indicating what was exactly happening with all the conditioning listed in there that is now possible in active CANopen FD error history. For that, there is an object existing 1032 was to have to be set. One of these objects is mandatory, but the list of the object is not. It is optional, but it may be wise to implement it if you want to have the history of your errors occurred in the system, monitor it, and be available for diagnostic purpose. There are a small list of new data objects emerged in there. We're just going briefly around them. We are close to finalizing about this, the basic CANopen FD functionality, and we come to the additional one. For that reason, you may also be interested in knowing what is new in parameters. So the device type allowing you also in classic CANopen to access the type of the device, to learn what is the type of the device. It's IO device, input, output, or is this drive or medical application device, lift device, whatever it might be. Now we put actually the effort to list all the logical partitioned device within one into one parameter, so-called logical devices. So you can put in one device, one physical CANopen device, you can put several entities which independently control, can be independently controlled. Such as, for example, you have a drive profile, but you would like to control all three axes independently from each other. There will be three logical devices. Now it is possible with this new device type to store information about these logical devices into the object 1000. So with one USDO access, you still be available to access only one device, but at least for diagnostic purposes, if you read those within the only object, you don't need to look for another object as we done at the last object of the object range for these logical devices. This all information is now available in object 1000, so it simplifies diagnostic. Object 1030, 31, 32 are solely for the purpose of versioning and error information, as I've mentioned before, much advanced. And active error list includes, beside the whole classic emergency, also additional information about timestamp and status of the network at this condition. And there are some other key features for more of the gateway or gateway and I/O bus couplers like object 1040, 1041, which is very useful. On the other hand, object 1041 is specifically designed for this long network routing within this logical virtual networks within one physical CANopen networks. That allows you to know where this USDO goes in there. Finally, there is object 100 F80, 1001 F80. We're currently working with it to create and adapt additional application functionality for CANopen with CANopen FD. We're still working on this. And I cannot say that we've changed that much in there, but we're working on this. There could be several cases, use cases we needed to consider before we adopt this for all possible scenarios that additional functionality can do in there, such as network detection, such as device detection in a network. Such things will require some additional control functionality, which we'll cover in this object 1F80. So beside this changes in objects, we said that the testing of the devices now is possible. Not only possible, but is also required. So CANopen FD conformance test, in which way whatever we offer is now obligatory. In a classic CANopen, it was still open, but due to the complexity of the device, it is necessary to make this be able to test them. So for the testing we offer for the moment is available on our website. The procedure consists of about 20 steps, which you can do yourself. You can find this on our, as I said, on our website. This is covering now the gap between now and then, the time when the conformance test tool will be designed for CANopen FD. We also use for our testing of CANopen FD devices this test procedure. So when you would like to start with CANopen FD, you should know that the protocol stacks with some advanced features are already available from companies listed in there, mostly Emotas and EMSA. A microcontrol offers protocol, but mostly the complete solution as well. If you don't want to spend your time preparing, designing application, and don't want to purchase only the protocol stack, then you can contact Microcontrol or ESD Electronics. They offer additionally such a way as the Emotas and EMSA companies that support complete design of your application for you. So a digital advantage, as I said, you can get if you want design part of those, you can get at least protocol stacks from EMSA and Emotas. We have basically already tested several devices. One of this, no, actually one is from EMSA. This is IO Gateway. This is the first CANopen FD device tested in there. And we have started actually adapting CANopen profiles to CANopen FD protocol. This is just summarization of what is going on and still going on, and some part of it is already done. You may find now the documents of ours having suddenly several parts, part B, C, and F. In contrast to the classic CANopen, part B means the technology-independent parameter list, while class C is for CANopen communication and mapping parameters for PDO, and CANopen FD is correspondingly for, and F is corresponding to CANopen FD. Just to list, to say a few words, there's 401 IO modules and 402 already supporting CANopen FD. Also encoder and inclinometer are now available in CANopen FD format. Although in those cases, I would say their mappings are, for the moment, are identical, to allow in the new devices just to make a build up on to the old technologies. So there are some use cases how the networks could be designed nowadays with using CANopen FD. What are the use cases we have? What are the things we are considering actually, and what we actually need to do yet for designing our additional application layer functionality for CANopen FD. In the next slides, we are closing the topic on CANopen FD. In general, basic CANopen FD goes to additional functionality. I would like to start with functionality you may know from classic CANopen. This is a part of the CANopen itself. These layer setting services, how you set up node ID within your device, and then configure your beat timing. This is actually a part of CAN device, but it's residing somewhere between the layers and is actually outside of CANopen, or in this case of CANopen FD. So in classic CANopen, we have LSS server, LSS specification. In a CANopen FD, they have the similar stuff, but we call now for CANopen FD variation code CANopen LSS FD. It has some specific functionality, as you may learn. I've just brought a few slides about faster scan using LSS to finding out if you configure the network, what are the devices, and find out the possibility to configure their node ID much quicker. But before that, you need to recognize the devices on a bus. For that is a faster functionality. LSS fast scan was developed. Now, in case of LSS FD, there is another good opportunity how you can do this much quicker than this, using certain bit patterns which enable of bit patterns, so twice 4-bit values, which will reduce the total number of operations for searching of each single device signature, which consists of, as you can see in the slide, of the device address of 4 subindexes of object 1018. It is then done with LSSFT much faster, especially with this selective FT protocol. Since you have no bridging into between the both technologies, so you would like, for example, to put CANopen into CANopen FD and vice versa, but there is in classic CANopen environment, we have not defined yet, up until now, we have not defined yet how to handle, for example, a mix-up the advantageous protocols of CANopen FD into classic CANopen environment. That bridge is been built by design of the specification 702, allowing to mapping of the CANopen FD services onto CANopen, classic CANopen environment on this way. Here is just an example of LSSFD functionality, which could be used to recognize a device in the network in CANopen, classic CANopen network much faster than it could be done in classic CANopen environment. Another thing, what is new, we have recently also development, is still work in progress, but we have some key features we have already with this technical report in progress. How to make usage of bit timing, proper optimal bit timing for low-speed applications. For example, as you're starting with that, with your low-speed applications, if you still use them, you would like to use advantages of the higher bit rate and advantages of a bigger payload, a part of the bit rate, a higher bit rate in case that you don't need to switch whatever you need. Imagine you have an application, you work with still with low speed, 250 or 500 kilobit in your network, but you use 64 bytes of CAN-FD. So you have to optimize your network also from the point of view of bit timing setting, so to allowing at least to have an optimal settings, assuming you use the same time quantum. Not assuming, but going from the point of view that the time quantum will be the same, which simplify the configuration of your device, at least configuration of bit timing in this case. There are some other key features which are not going in details. How we fit the existing CANFD advantages into the classic CANopen network, or even optimized CANopen FD network, or let's say in general industrial CANFD applications with same classic, or let's say lower bit rate, but higher payload of 64 bytes. That is also in this specification you will find. And since we're not finished yet, we would like also to get your feedback. Possibly you may have some additional information, additional requirements and suggestions. Maybe you have designed already such an application and you have found some issues, or maybe you would have some features in there. So you're kindly welcome to join our task force working on this group. For that, I would kindly ask you to write us down. If you're interested, then there's the name of specification. Then we would inform you what is the working group working in this. So there are a couple more slides in there. Hope we're not that much over the time in there. Hope you still have a couple more minutes. There are other development, bootloader and redundancy stuff for the moment that we are quite made a lot of progress. The task force bootloader works on the optimizing the functionality of every CANopen FD bootloader, allowing to harmonize features was present also in classic CANopen to be able in there, and harmonizing to design of the bootloader across various applications, which was not yet done in there. Also in this case, despite this is a final commenting stage, if you have occasionally suggestions, some requirements, some other things, maybe issues you've encountered over your past experience, you're also welcome to contact us on this topic and give us some information on that. So redundancy, that you might also have heard about this. We also have a special working group on that, optimizing the system redundancy, network redundancy, device redundancy, and so on. We've designed specification 701 for that reason. This is currently still a work in progress. Also here, I would like to inform you that we are interested in your feedback on this one. So we make the specification quite suitable for most application using redundancy over CAN protocol. Due to lack of time, I wouldn't just concentrate on these topics. We have just a few slides to inform you beyond CANopen FD that we have several technologies. Or maybe one slide I'll show about how CANopen FD would look like using this new protocol and so on. As of right now, in this slide, you can see we have 3 CAN-based technologies. CANxl is already standardized. This is third technology, allowing to do some pretty amazing stuff. Have a fixed bit rate, 10 megabit, 20 megabit payload, much larger than FD. This is even larger than Ethernet frame. In fact, matter of fact, it can the Ethernet frame can be completely put into CANxl frame. There was the idea also behind this, so that the gateway, in-vehicle gateways, for example, could reuse this nice feature to exchange between their Ethernet and CAN-XL-based networks. Technology is still at some point in the development. For higher layer application, there are, of course, certain advantages. The payload is much bigger. The speed is also there. But that should be looked more detailed in there. What would be the key advantages for higher layer protocols such as CANopen? What can be of use in there? But for the moment, CAN-XL microcontrollers, I'll say hardware protocol and hardware and physical layer is available only to the limited number of the companies, is not widespread. It will be possibly in 5 more years, maybe even longer. So, but we start also to look into this, to have compile the key advantages it may bring with itself, what it has a future, what is point to the future of CANopen, let's say CANopen XL, whatever. Has it some backwards compatibilities? Can we maintain backwards compatibilities in CANopen XL, in CANopen FD toward classic CANopen with introduction of CAN-XL protocol for CANopen FD, for example. So there are still answers we hope to resolve, and we are currently looking into the most advantages it delivers with itself. But for the moment, XL-based CANopen is not in the highest topic. CANopen FD on CAN-FD based and application or maybe mapping of CANopen FD services onto CANopen networks is quite a bigger topic of today. So that is mostly all. Just want to point you out to our social media access to the next webinars of the time being. The webinar list you have seen just briefly, you can find on our website. And there is our contact data for those who have not known us before. You're welcome to contact us.